Pre-Calc. This section in the pre-calculus textbooks, section 3.2, it's on families of graphs, and you should have some experience with this from Algebra 2. Some of the problems may be a little more involved, but for the most part, the basics should be the same. A family of graph is a group of graphs that share one or more characteristics. They're going to basically have the same shape. They're going to move on you. They may rotate or reflect or change steepness in the starting points, but they still look the same. Parent graph is the original graph, and it can be transformed to create all the other members of the family. The parent graph is always going to start at the origin 0, 0, so that's also a good note to make. These graphs can be reflected, flipped, translated means move, like slide right, left, or changing steepness to create another problem. We're going to run through this quickly because, like I said, you should have had this in the past. There's different types or families of graphs. The one category you've been working on for years now is linear. Linear are basically lines, and so there's different ways to draw lines. If a function is constant, it means it's a flat horizontal line. It can be moved anywhere and cross the y-axis at any location. The identity linear family is basically a rising diagonal line, but the slope is always 1. Please notice again, in this case, because it's a parent graph, that it does cross at the origin. Now, the constant graph in the previous picture does not, because, like I said, this can be drawn anywhere on the grid. Direct linear family is a family that's still a rising diagonal line. This actually could be a falling line as well, because the slope here can be any number except for 1. And then the y-intercept is still the origin. So it could have a slope of, in my case, I think mine is 3. You can go to the origin and then count up 1, 2, 3, write 1, 1, 2, 3, write 1. So in this particular drawing, the slope is a positive 3 because it's rising up 3, write 1. Again, the B, because it's a parent graph, starts at the origin. So family number 1 is linear. Linear. These are just specific examples of that family. Number 2, second family, is called quadratic. To be quadratic, it must have a power of 2 in the problem. So the parent, this is called, again, the parent graph and parent equation, is one that starts at the origin. Notice my picture below. And if it's a quadratic function, you did this in Algebra 2, the graph should be U's. They're called parabolas. Okay, it's kind of spelled like parabola, but you do not pronounce it that way, okay? It's a parabola, U-shaped graph. Quadratic. The third family is cubic. Cubic functions are ones that have a power of 3. Again, this is the parent equation, and this is the parent graph. This is located again at the origin and rises in the first quadrant and goes down in the third. But what we'll do is we'll take and add numbers and subtract numbers and move this graph around. We could slide it right, left, up, down. We could reflect it. We can make it look wider, like this. We can make it look skinnier, like this one. And that all depends on the numbers they give you in your problems. So any change or transformation we do to the parent equation is going to create another member of the family. The third or the fourth family is the square root family. Again, this is all from Algebra 2. Square root is y equals square root, or the radical x. The graph does start at the origin, please notice, and at this time it rises only in the first quadrant. It looks like a little arch or like a little rainbow, part of a rainbow, and so make sure that you don't draw that straight. it is an arched graph. The next family is called the cube root family. In order for it to be a cube root, you would look for this symbol in the problem. Very simple. And the graph, the parent graph, starts at the origin, and it continues this kind of a curve here. It continues in the first quadrant and then goes back into the third. So it looks like a stretched S. Stretched S. Notice that the cube root function and the cubic function are just turned different ways. Be really careful though and make sure that you memorize the pictures and you have that in your head so you don't mix those up. The next family is called the absolute value family. This one you also have had in the past. Absolute value family, you're going to look for your absolute value bars. The graph is going to make a nice V graph. And if it's a parent graph, like I said several times already today, it's going to start at the origin. Another family member is called the greatest integer or step function. The way you're going to tell if it's a greatest integer or step function is to look for a double bracket. If your problem has a double bracket on it and you just see y equals the greatest integer of x, this is again the parent equation. It's going to start at the origin. Now what I want you to notice in my graph is that I have actually made this graph paper, I've changed like the labeling. So I skipped 3 boxes and called this 1. Skip 3 more boxes and called this 2, and so on. And so I did that so you could actually have more space in between it and you could see what I was trying to draw on the screen. So it's a flat horizontal step. It has a closed circle here and an open circle here. Closed circle on the left, open circle on the right. And the same deal, it continues that same pattern over and over. Next family is the rational family. Rational family is the family that the equation has a division bar in it. A good way to kind of picture this, I can write it this way as well. Look for 1 over x. When you have a problem of that nature, the graph is going to have what's called asymptotes. This is a word you may not have had in the past. These are the pink lines that I've kind of drawn in on top of the x and y axes. And those, again, are called asymptotes. Don't worry so much about that right this second. But it's basically a boundary. The blue is the actual graph. The blue has to get close to the pink asymptote without crossing over. The reason there is an asymptote in this picture, by the way, is if I were to put 0 in place of x, I would get 1 over 0. And that, of course, on a calculator, it says error, undefined. No answer for that. And so that's why there's an asymptote. There's no way that I can put 0 in place of x and get an answer back for y. Alright, let's briefly review the transformations or shifts in graphs. The first thing you would want to do, of course, is recognize what kind of family you're dealing with. So in this particular one, the math symbol that really is key here is the one I'm highlighting. This one is a quadratic. I know that because of the power of 2. And so one of the first things you want to do is make sure you're comfortable with learning all 8 families and knowing how to recognize them very quickly just by looking at the equation. Okay, once you do that, that should be step 1 in your study process of this unit, and then you should also have a mental picture of what the graph looks like, and then the rest of it will fall into play. Again, step 1, start memorizing the family names and the symbols they use in equations, and then step 2, memorize the graph, like what it looks like with the name, of course, and then the next part will be you understanding how to transform or shift or move the graphs so that they land in different places. So back to this problem, it's quadratic. I know quadratics are parabolas, so this graph is going to look similar to this. It's going to be a U-graph. There are some numbers that are super important. The number that is the number being multiplied by the parentheses which is also essentially the coefficient of the x squared term. If I had FOILed this out, that number determines a couple things actually. That's called the A. Okay, so the A determines the direction of opening. If A is positive, it's going to open upward, and if A is negative, it's going to open downward. The second thing that the A does is it determines the steepness. If the A is greater than 1, let me do it this way. Then it's steeper than the parent. If A is less than 1, but still greater than 0, so let me write it this way. If it's between 0 and 1, then it's less steep than the parent graph. Okay, so A determines two things. The A is the green highlighted number in this particular problem, and it determines the direction of opening, whether this parabola is going to open upward like mine, or if it's going to turn over like an upside down U. And the second reason this is important is the number without the sign determines the steepness, like how skinny the U is going to be made, or how wide, and so forth. And again, the important parts to that is paying attention to this symbol. And so if A is greater than 1, it's going to be steeper. But if A is between 0 and 1, like fractions, 1/2, 1/8, 3/4, then it's going to be less steep than the normal parent graph. Okay, that again is the B. Or the A, I'm sorry. The B is the number that will determine the horizontal shift. And so, type this out here. So we're making all these notes in our own notebooks. So the B is important because it's the horizontal shift. It moves right if the number is subtracted, so it's actually opposite as to what you think it would be. And then you're going to move left on the graph if the number is added to x. So move right if it's subtracted, and move left if it's added. So in this example, where there's a plus 3, 3 is being added to x. According to this, if it's added to x, this 3 is going to actually move the parabola of left 3. Parent graph starts with origin, but it's going to shift it back. Okay, the number at the end, and in my case is -5, that number is going to determine your vertical shift. So I'll grab purple for that, and that is called the C number. The C determines the vertical shift, and the directions you need to remember is that you're going to move up if the number is added to entire equation, and then you're going to move it down if the number is subtracted to the entire equation. Okay, and so those are the important pieces there. So we need to know by looking at an equation, no matter what we're given, we first have to identify what family it belongs to, and we again have 8 categories to put it in. After we decide what category it's in, we have to have a visual, like in our head, an idea of what the picture should look like. Then we have to know what the parent graph does, which starts at the origin. And then we have to take the transformations, the A, the B, and the C, and know all of this, okay, and know how it impacts the graph. So we're going to take this one step at a time. I'm actually going to, we'll start with the A. And because the A in my problem is negative, that means that my parabola is going to open down. So I would just kind of make a quick note, and I would say opens down. Alright, then you would need to also look at just the number 1/2. 1/2 is not greater than 1, but 1/2 is between 0 and 1. So then I would make just a quick comment that it's less steep. And yes, you do need to write the words down when you're on your own and you're practicing these problem sets. So opens down and less steep than the parent. Next, your B. So your B is 3. It's actually positive 3. This is going to cause the graph to move left based on the notes. Move left 3. And then this 5, we'll put this up here. This 5 is the C, and the C is the vertical shift. My 5 is being subtracted from the entire problem. So if it's subtracted, let me go back and highlight this. If it's subtracted, then we're going to move it down. Okay, so we'll put all these little notes to ourselves together. We're going to move left 3, down 5. Let me write that down. Move left 3, down 5. The parabola is going to turn like open downward, facing downward, and it's going to be less steep. So put all that into action. I always start with the B and C first, so that way I have a vertex, like a starting point. So from the origin, which is the parent graph, I'm going to move left 3, I'm going to go down 5, and that's going to be my start. Then I'm going to pay attention to the steepness. It's less steep, it's going to open downward. So instead of me drawing like this graph maybe, I'm going to draw one that's like half as steep. And so what you really have to do is know, like, well, what does that mean? How steep is steep? Steep to me may be different than steep to you. So what a good way to do that is to, you can use your calculator too and just go to the table and pick out some values. You can just go to, like, if my vertex is at -3, -5 right now, and that's what this point is, then very quickly I can just go to a table and say, what happens if I use -1? If I put -1 in here, what kind of problem is that going, or what kind of answer is that going to be? So I'm going to do this very quickly, and again, you have the calculator to make this faster for you at home. But -1 plus 3 is 2, 2 squared is 4, 4 times -1/2 is -2, and -2 minus 5 is -7. So at -1, I would go down to -7. And then I would try that maybe for -2 and -4 and -5, and kind of think of it in those terms. And so this is just kind of a rough sketch. I did try my best on this graph to model that, but the blue point is the starting point. That's the vertex, and again it's -3, -5. Okay, so make sure you really understand all of this right here. The A, the B, and the C. Okay, let's go on. Let's look at number 2. Number 2 is the family. I see bars. That is absolute value. I should know in my head that that's the type of graph that makes a V. I'm looking for my A, my B, and my C right now. My A is the number being multiplied by the absolute value bars, and in this case, that would be the 2/3. So we're going to pause right now. Again, please notice this number is being multiplied by the absolute value bars, so that's why it's the A. And this one's been turned, like the equation's been written differently, so you really do have to pay attention to the location. Let's go ahead and describe what that means. If a graph has an A of 2/3, first it's positive. That means it's going to open up. And if it's 2/3, it's less than 1. That's a fraction, so it's going to be less steep than the parent. Okay, for the B. Well, the B is the number that's being added or subtracted to the X. Well, in my case, it's here. It's going to be the 4. And so since the 4 is my B, it's actually subtracted. And so what that's going to do is that's going to, look back at your notes, that's going to create, where it's subtract 4, it's going to move it right 4. Okay, third is the C. The C is the numbers being added or subtracted to the whole problem. And so what might make it easier up front is if I would have rearranged this a little bit and done like y equals 2/3 times the absolute value of x minus 4 and put that big plus 3 at the end. That might be easier to see. But this is my C. Okay, and now you just explain what that means. Well, if it's a positive 3, that's my vertical shift. That's going to move the graph up 3. And then you put it all into action. Again, always do your BCs. That way you can get your ordered pair. Okay, so from the origin, which is where the parent graph starts, I'm going to move right 4, and I'm going to move up 3. So my location for that ordered pair is 4, 3. Simple as that. And then I need to know opens upward, so it's going to look like a V and not like an upside down V. And it's going to be less steep than parent, and so this is where I use either a table, calculator, like table, or I also can do this, 2/3. I can go like up 2 and right 3. It works really well in absolute value because it's symmetric. I can go up 2 and left 3. And let me rephrase that. So slope in a absolute value equation, you can really treat it like the lines and do like rise and run. So up 2 right 3, up 2 left 3. Remember, the graph is symmetric. That's what I was trying to say. The graph is symmetric, and so that's why this slope works by counting. Kind of just wanted to share that with you, and you can get a really good graph. So don't just estimate what you think looks like 2/3. Go ahead and count, and that way you land in the right place. Alright, so this one on number 3 would be considered step function. I know that because I see the double bracket there. Again, my A is the number being multiplied by the family. My B is the number being added or subtracted to X, and I want you to notice that inside these brackets, I don't see a plus or a minus sign. So in this case, there's 0 number added to X. And then my C is the number added or subtracted from the whole problem, and that's going to be this minus 1. Based on same criteria, we'll start from the bottom. If it's a minus 1, that means it's going to move down 1. The B is 0, that means move 0 units right, left. Basically, don't move at all from the parent graph. And then the step function, this one is different from the others because this doesn't determine, it determines the direction. It's definitely going to go like up because of the fact that it's positive, but the 3 does not mean steepness. And so this means you're going to actually, I'll type this out, you're going to skip 3 units between steps. Alright, so let's see how this works. I'm going to move 0 units from the right or left, so basically I'm going to get to stay here. And I'm going to go down 1, there's down 1, and then I'm going to create a step function, which means a horizontal line 1 unit long, and this time I'm not going to like space this out. I'm just going to count this as 1, 2, 3, just like you would any other day, and then the open circle at the end. And then you're going to have to repeat the pattern, but this time the A is 3, so instead of me jumping like straight above it, I have to go 3 up. So up from here, 1, 2, 3, land there, draw your next step, open circle. Try it again, jump up 3, 1, 2, 3, close circle, line segment, open circle. One more time, up 3, 1, 2, 3, close circle, line segment, open circle. And so that's the graph that it creates. This is a transformed member of the step family. What I like to do on these types of graphs, because the steps all look the same, is once I figure out what the A, B, and C are, I always like to highlight my original step. And that would be my suggestion to you at home. When you're doing problems like this, have a highlighter or a marker handy, and when you get to this particular function or family, you do highlight the original, because it's easy to lose your place. It also goes in the opposite direction, so from here you can go down 3. So 1, 2, 3, open circle there, because it's still got to pass the vertical line test. So every time you have a closed circle, right underneath it or right above it should be an open one, I should say. And so the pattern just continues like this. Okay. Alright, moving forward, let's try 4. This one's important based on the way it looks. I do know that it's cubic, and the cubic function, according to my notes, is one that models this type of picture. Okay, so at least I have that. But the issue with this one is my negative number is actually inside parentheses, so I've got to be more careful on problems like this. You need to make sure that you actually evaluate this problem. So it's negative 2x quantity cubed means I want you to picture negative 2x times negative 2x times negative 2x. Well, negative times negative times negative is negative. 2 times 2 times 2 is 8. And then you'll drop your x to the third down, minus 4. Be really careful on those problems. Okay, when you get to that point, you're then going to write down your A. Remember, your A is the number being multiplied by the function. The function is x to the third, so your A is negative 8. Please notice in this one that the B is supposed to be with the x, and we're used to problems looking like this, with parentheses or something going on like that, where that's the B, and this is the C. Notice that this problem doesn't have parentheses, and so the B again is the number being added or subtracted to x, and right now it just says x to the third. So there's 0 B in this one. That negative 4 is the C because it is taking 4 and subtracting it from the whole problem. So that's the big difference between B and C. I've tried to repeat that several times in the video, just make sure that you keep that in mind. I'll say that one more time. The B is the number added or subtracted from x. The C is the number added or subtracted from the entire equation. And then you'll start describing in your practice set what's going on here. When A is negative, it's going to open down. When the A is up 8, remember, after you do the sign to leave it off, so the A is 8, that's going to be steeper than the parent. B, do not move left or right. and here down 4 units. And that's from the vertical, so from the origin. We go back, hanging in there. We start at the origin, that's where the parent graph starts, but we don't move right or left. All we do is go down 4. So my vertex, or my starting point, is the place at 0, -4. Then I go back and say, okay, it's a cubic function. I know the graph's going to do this. Oh, but my a is negative. And so now instead of it going like this, it's going to reverse. It's going to flip. And it's going to be steeper. And so I would do like, this is me estimating right now. You'll have the graphing calculator to make sure that you land in a couple different places here. But that's what number 4 would look like. Okay. All right, number 5 is a square root function. That's the square root family. Square root family is the one that has like the little rainbow looking thing. And so first of all, after I label it and know what the graph looks like, I find my a. My a is going to be -1 because it's the number being multiplied by this math symbol. My b is the number being added or subtracted from x. In this case, it's going to be that 3, and it's actually a negative, so it's going to move right 3. Move the graph right 3. Okay, my c number is +4, so it's going to move up 4. Okay, and some of them are going to be this simple. Once you get the patterns like transformations in your head, it's not too bad. And then on the a, I see a negative, so it's going to open downward or flip or reflect. You can say other words too. You should have learned that last year. So reflect, flip, turn upside down. And then the 1 is equal to 1. So when the number is a 1, I should say, you can just write same steepness as the parent. Same steepness. Alright, so let's take care of that. Let's go over here, move right 3 from the origin. 1, 2, 3, up 4. And there is my starting point. Right 3, up 4. My starting point has the ordered pair, 3, 4. I'm going to use the same steepness, know that it's a square root function, so my graph looks like that, but it has to be flipped. So instead of me drawing it like this, that's incorrect, I would need to draw it underneath and flip it. Alright, let's see which ones we're going to do. Okay, we're going to make this be error number 6. And our last one for today's notes. And what I want you to notice about this problem is there's a big division bar. And so if it has a division bar in it, from earlier notes, it's called rational family. And the parent graph I have shared with you today, it has the one that has the 2 asymptotes, and it's moving in like the first quadrant and the third quadrant. Okay, and so here's how we handle the ABC. I'm actually going to start with the C this time. The number being subtracted from the entire problem is the -2. So what that's going to do is it's going to move the graph down 2. Where this one has an asymptote, it's actually going to move the asymptote. This is how you spell it. It's a weird looking word. Asymptote is a line, like a boundary line, that the graph gets really, really close to, but never crosses. My B is the number being added or subtracted to the x, and that's going to be -1. Because it's a subtract one, it's going to have the opposite effect. It's going to move the whole graph right 1. And again, because we're talking about asymptotes, it's actually going to move the asymptote which essentially is the whole graph, right 1. Now, the A is the number supposed to be multiplied by the family. In this type of problem, it's usually the number in the numerator of the fraction, so it's going to be 3. Because it's positive, it's going to kind of model this one. Okay, it's not going to be flipped. And because it has a 3, it's going to be steeper, which means it's going to be with respect to the asymptote, closer or farther away. So you'll have to use like a little table to tell. Steeper. Alright, so we'll go with that. And now we are going to model the asymptotes. So the first asymptote moves right 1. So the original parent graph was right on top of the y-axis. Well, this time we're going to scoot it over 1 and make it look like that. Sorry, that's a little bit crooked. For the C, I'm going to go down 2. Well, what am I moving down to? I'm moving the asymptote down 2. So usually it's on top of the x-axis. If I shift it down 2, it's going to be there. Okay. All right. From that perspective, looking at that equation or that graph, now I need to figure out how to draw this. And so, with rational functions, you are going to have to use a table. You're going to have to write your equation in the middle, so you're going to have to show me some work here. You can also use your graphing calculator and the table in it to make this faster, because we're just trying to learn the main points to this in this section. And here's my x values. And so what I would ask you to do is pay attention more to the vertical asymptote. Notice that this is crossing at 1. So I would choose like numbers to the left of 1 and numbers to the right of 1. So I would use numbers like -2, -1, 0. I wouldn't use 1 because 1 is the asymptote. Then pick numbers to the right of 1, like 2 and 3. And then you'll take each of these numbers, plug them into x, figure out what this is, and then record your answer here. When you do that, you'll get a much better idea as to what's happening. Okay? So I'm going to do a couple so I can kind of get started. If I do a -2 right here, that's going to be -2 minus 1 is -3. 3 divided by -3 is -1. -1 minus 2 is -3. So at -2, I've got to go down -3. And I know I'm talking quickly, but again, you have a calculator at home, and you can pause this and then work through it. And when I do -1 here, the bottom's going to be -2. 3 divided by -2 is like -1.5. -1.5 minus 2 is -3.5. So when I go to left 1, I go down 3.5 right there. When I do 0, that's going to be 0 minus 1 on the bottom is -1. 3 divided by -1 is -3. -3 minus 2 is -5. So 0, -5. 1, 2, 3, 4, 5. Now I'm going to stop there with this one because the asymptotes are my boundaries. I cannot go across them. So that's going to show me how to kind of model the graph, make it curve so it matches the one I shared with you on the previous screen. And then over here, I'm going to jump to like 2, see what happens. If I put 2 here, 2 minus 1 is 1. 3 divided by 1 is 3, and 3 minus 2 is 1. So 2, 1. And I'm going to kind of just sketch this one in. But you are to complete this entire thing. So rational usually takes the longest. You are going to have to list your A, B, and C, but you have to provide me a table. If you use the graphing calculator, that is fine, but you still have to record the table on your paper, and that way I can check your points to see if they match mine. Okay, again, this entire section is one that should have been covered in Algebra 2. It's about transformations and shifts of graphs and the types of families that we've covered. And remember, there are 8 of these in this section. So linear, quadratic, cubic, square root, cube root, absolute value, the greatest integer or step function, and rational.